In this video, we'll see how we can deploy any machine learning model in canary mode. And then further, we'll see how we can deploy it using incremental rollout. So these are the deployment strategies which we normally use for the deployment of machine learning API in production. And this is a continuation of my last video where I had tested random forest API in shadow mode, and we are happy with the performance of my random forest API because we had done an extensive amount of testing for considerable amount of time using the live customer traffic. And now we are happy to open the traffic to accept the request from random forest API. And that's the purpose of canary and incremental rollout. So what it means that on day one, we will not open the entire traffic for random forest API because this is a new version of my improved version of the model. So in practice, what we normally do will slowly migrate the traffic from my old model to new model. So initially the percentage of traffic coming to the new version would be less, but slowly we'll migrate the traffic from my actual decision tree classifier, which was my initial main endpoint for accepting any traffic from my client, and we'll migrate that traffic to random forest API because that's an improved version of my API. So that's the context we have, and in this video we'll see how we can implement those strategies using reserve package. Okay, so this is again the same set of instructions, so we are not going to discuss about these aspects where we had implemented decision tree classifier using loan default v1, which is exactly same to what we had done in previous video, right? And this is the random forest classifier where we had built loan default v2 ml API, right? The thing we will discuss in this video about the changes which would be required for making it as canary or incremental rollout. Okay, so here you can see that we are connecting it to existing running serve instance. Okay, so probably what we will do, we will simply run it and then I will explain what it means. So I'm just running it. It will launch ray cluster. I will create decision tree backend. It will create decision tree endpoint. Okay, so you can see that HTTP server has been started, right? So this is that HTTP server based on the UV Okay, so it has been started, and now you can see that my endpoint has been registered. So that is done. Okay, so we'll not run this because we have already seen it, and now we'll run random forest. Okay, and now we'll explain because here the actual changes we have for canary deployment. So here I am simply connecting it to already running serve instance with the help of serve.connect. Right, so here you can see that my serve instance was started with the help of serve start, and here we are simply connecting it to the same instance. And here as a part of second step, we are creating a backend for random forest API, and this is the main thing where we are setting up traffic, and we are setting up traffic for this endpoint sklearn loan default, and what we are saying that just send 80% of the traffic to loan v1. So loan v1 is based on decision tree. We'll just cross check. So loan v1 is based on decision tree classifier. Okay, loan v1 this is, and this is based on this version of API, which is decision tree. So that's what we are saying it here. Send 80% of the traffic to decision tree main API, and remaining 20% of the traffic should be routed to random forest, which is lone v2, right? So that's what we had defined here. We had created lone default v2 for random forest classifier, and we are setting up traffic here. So once this would be performed, so whenever you will access this endpoint, the main endpoint, so the important thing is that your endpoint would not change. So customer will always hit the same endpoint, but internally what RayServe will do, RayServe will randomly distribute the traffic between lone v1 based on decision tree and lone v2 based on random forest in 80-20 distribution. So that would be purely random, and you will see this in practice. So whenever I will run this command, I'm just running it. So when I will run, so you can see version v1, so decision tree, it's hitting decision tree. Okay, we'll see. I think I haven't run this statement, so I will run this statement, because initially we had run all the cell till this point and this was not executed, so that's why it's not reflecting here. So now I have executed it, and once it would be successfully set the traffic, then we would be able to see those changes here. So just, it will take some time, probably 30 seconds more, and then we would be able to see how my RayServe would be splitting the traffic between decision tree and random forest classifier. Okay, so that is very important concept in any machine learning deployment API, because in this way you can migrate traffic from one API to another in an incremental way. So here I'm just defining this as initially 80% of the traffic to this and 20% traffic to v2. And in next step, what I will do, I will just switch the traffic. So now lone v1 will have traffic 20%, and lone v2, which is based on random forest, 80%, right? Because as a part of this step, we have seen that we are okay with the performance of random forest API, and probably we can increase the percentage distribution of random forest. So that's what I have done it here. I have changed the percentage distribution from 80 to 20 and 20 to 80. Okay, so now you can see that it has been executed, and now we'll try to run this cell, and now you can see that the distribution would be spread between v1 and v2. Okay, it's v1. Now you can see it's v2, right? So 20% of the traffic would be routed to v2 instance. So you can see that it has received one request, right? So it's basically random. So again we'll run the same cell. You'll see different type of distribution. So it's not exactly 20 every time. It will randomly send the traffic to both the classifier. So here you can see that we have received one message for v2, and now you can see the second v2 instance. Okay, so in this manner it will split the traffic. Okay, so we are getting traffic for both v1 and v2, and in appropriate distribution, 80-20%. And now we will run this statement. Okay, and now we'll see how much traffic my version v2 would be getting and how much v1 would be getting. So now you can see that v2, we are getting the v2, we are getting a response from v2. That means the traffic has been routed from v1 to v2, and you can see that couple of requests from v1. See, right? So everything has been reversed now, right? So initially we had all the traffic going to V1 and few to V2, and now all the traffics are going to V2 and few for V1, right? And the main thing you'll notice that the serve URL would remain same. We are not changing to serve URL. So from client perspective, it would be hidden. Client will not know which API would be hitting internally, right? That's the benefit of implementing the canary or incremental rollout deployment strategies. Okay, and now we are happy with the random forest classifier, and now we want to stop accepting any traffic for my old machine learning API, which was based on decision tree. So I will give the distribution as 0 and will route entire traffic to V2, right? So now we'll execute it, and now we'll send it. And now what you will see that entire traffic would be routed to V2 and none of the requests would be received by V1 model. So now you can see that everything has been routed to V2 instance, and you will not find out any single instance where Ray service routing it to V1. So that's the concept of incremental rollout and canary mode, right? So you can see that everything has been routed to V2. So at the end, we'll close the Ray cluster, right? So these are the very important concept from machine learning API deployment perspective, where we don't open the traffic upfront for any improved version of machine learning API, and we use a combination of shadow testing and canary and incremental rollout for machine learning API, because that will make your deployment much more robust to failure, and you can simply roll back to any previous version with minimum delay or minimum impact, right? That's it for now. Thank you.